Hey there. So we're treating the circle theorem, we're dealing with the circle theorem. But first, before we can solve this question, let's try understanding what we mean by a circle and what the parts of a circle are. The first rule with this A, B, C are equal. Why? Because you know the chord, that line that cuts the circle at any point other than the center is what we call a chord. So A, B, C are equal. So let's write this one down. So angle of A is equal to the angle of B, which is the same as the angle of C. Note that the chord doesn't pass through the center. This is the center of this circle. It doesn't pass through the center. So then any point which touches the circumference and has the same chord, the angles are the same. So let's look at the second diagram. So the angle a chord subtends at the center, O, is twice the angle subtends at the circumference of the circle. So for example, giving an example to be having A to be equal to 30 degrees, what do you think B will be? Because it has the same chord, angle B will be 2 times that of A. So 30 is equal to 2B. Therefore, B is equal to half of this, which is 15 degrees. Are you getting it? So the rule number 3, the sum of the angles a chord or the arc subtends to the circumference of opposite segment of a circle is equal to 180. So A and B here is equal to 180. Okay, sure. So with the next rule or the next theorem, the line passes through the center. So what is it called? The diameter. So when you have this situation, it subtends to one triangle here, another triangle here, giving us 90 degrees. So in case you are giving angle here to be 45, definitely this side here is also 45. Okay, so then if you are giving this point, we have this angle to be 20, making this whole angle to be what? 65. It means that to find for this angle, say x is equal to 65 is equal to what? 90. Therefore 90 minus 65 is equal to x, and x here is equal to, have this angle to be 25 degrees. So just be playing around the rules, okay, much more. So let's pick the next rule. You can see that here you have two sides being equal, this side and this side. So the chord here is equal to the chord here, and therefore the equal chords or the area subtended are the same angles of the circumference. So we have x to equal to x. So once you see that you have the same equal number of chords, is this way. Okay, we have equal chords. Why? Because they are noted in this side. Once they have the center, you have equal chords. These angles must be equal. Okay, so let's say you have this side x to be 4 degrees. Definitely here will be 4 degrees. If x is equal to 34 degrees, this side is also 34. This side, the opposite angles of a cyclic quadrilateral are supplementary. That is, they add up to 180. DB to be equal to 180. CA to be equal to 180. Are you following? So the opposite angles sums up to 180. In this example, we are told to find the angle between the x, q, y. So let's label this part to be A. But note that from the rules here, you can see that the angle between the chord and a tangent at the end of the chord is equal to the angle in the other segment, these angles. Okay, So we have this to be, this side means that once this side is 41, definitely this angle here is 54. So then to solve this, you know that 54 plus 41 plus a is equal to 180. Therefore, making a the subject, we have 180 minus we have 95. So then a here is equal to 85 degrees. So in this question, I'm told to find for angle A. And from our angles, we know that A here plus this 90 here is equal to the angle outside. So then A plus 90 is equal to 4A plus 12. So making A the subject, bring A here. So 90 minus 12 is equal to 4A minus A. We have this to be 78 is equal to 3A. Divide both sides by 3. We have this side to be 26 degrees. Having a question like this, you are supposed to find the angle theta. But first, before you can solve this, what clue do you have over here? I can draw an imaginary line here. Same here. So they have what? An angle having two opposite sides. We draw our chord. So then we can use the root 3. That is the opposite side here being equal to 180 with the same chord. So then here, so then have this to be, let's say, A. So then 138 plus A is equal to 80 degrees, 180 degrees. So then A is equal to 180 minus 138. So then A will be equal to 42 degrees. From this side, from this rule, the circle theorem is all about rules. We have this side. Okay. So then you can see this same drawing here. But it's turned around, okay? So then to find for theta, we know that theta is 2 times E from this rule. A is 2 times B. So then we come here, we write that two times of A is equal to theta. Therefore, theta is equal to 2 times 42 degrees. 2 times 42 is 84. So in circle theorem, it's all about applying the rules. Okay, we're supposed to find the angle Y. We know that they have the same chord. Therefore, from this rule, because subtends to the same chord, angle C is equal to angle A is equal to angle B. Therefore, with the same chord over here, Y here is equal to 48 degrees. Angle X. We have to find the angle X. So before we find the angle X, first in circle theorem, always break everything down to the simplest form. You pick the first rule. If it's not that one, you move on. So with this side, I'll label this. This is the question given with the angle is given, okay? You have to find the angle X. But first, how can we find for X? Before you can solve for the X, you know that from here, vertically opposite from angles. So we have this angle to be 70. So then we know that from here 65 plus 70 plus x rather is equal to 180. Therefore 45. So note, one would have even solved for this side to be 65 degrees because it subtends to the same chord having this triangle and we're messing around. But once you know that this is vertically opposite angles, you put in the 70 over here, just solve 65 plus 70 plus x is equal to 180. You solve for your x and you're good to go. So in circle theorem, note that it's all about applying the rules.